Okay, so hopefully now we are all in the right spot, graphing linear equations in standard form. Now don't forget, standard form is something we already learned, but we did learn it before break. So standard form equations look like this. 2x plus 4y equals 8. I am just jotting this on the side if you would like to as well, just so that you have the notes, that's great. But we will be using this side to actually graph. So here's what standard form equations look like. In previous sections, guys, I would ask you to take this equation here and graph it, find or use x and y intercepts to graph it. So a question I would give you before, a couple weeks ago, would be find x and y intercepts. Now this is something we spent a few days on, but it has been a while, so you might have forgotten what this means. This form of equations looks different than the form we were just working with. The form we were just working with was y equals mx plus b, and all of the equations were solved for y. These equations do not look like that. They have the number with x here, a number with x, or number with y here equals a number. These, though, can easily help you find x and y intercepts. If you remember, to find the x-intercept, you take the equation 2x plus 4y equals 8, and to find the x-intercept, you make y equals 0. You basically cover this up, and you solve the little equation 2x equals 8. I hope this is coming back. To solve this, we would just easily divide by 2, and we get that this line has an x-intercept of 4. So if I was to graph this one, I would plot a point on the x-axis at 4. To find the y-intercept, we use the same equation, 2x plus 4y equals 8. But instead of covering up the y, we want to find the y, so we cover up the x, and we solve the little equation 4y equals 8. We easily do that by dividing by 4, and we get y is equal to 2. So we actually spent a couple days on just this here, finding x and y intercepts and then graphing x and y intercepts. If I said graph this on a coordinate plane, what you would do is you would take this number here. This means on the x-axis at 4, 1, 2, 3, 4, make a point. And on the y-axis at 2, 1, 2, make a point, and then graph your line. That's how you would graph this using x and y intercepts. These equations to the left here are all in standard form. We could easily find the x and y intercepts and graph these equations that way as well. But there's a new way we can graph, and it's by taking these equations and converting them to slope-intercept form. So the equation negative x plus y equals 1 is currently in standard form. Slope-intercept form is in the form y equals mx plus b. It looks crazy, but basically all of the equations that are in slope-intercept form are solved for y. So what I can do if I am being asked to graph these using a certain type of form and not using this method here, what I would do is take these equations and I would solve them for y. So one way to do that, I'm just going to rewrite this down here. Negative x plus y equals 1. If I was to take this equation in standard form and solve it for y, you could circle the variable you're solving for, which in this case, it's always going to be y. And then you have to move everything else that's on the same side of it to the other side. So to move a negative x or negative 1x to the other side, we always do this with addition or subtraction. So because it's a minus sign or a negative sign, the opposite of that is a positive. So I would add 1x to both sides. Those cancel out, and I'm left with y equals. And I'm going to write the x first because the number for the slope comes first. And this turns into y equals 1x plus 1. What we did was we took this original equation, negative x plus y equals 1, and I converted it. I solved it for y. So I took this minus x and moved it to the other side through addition, and I now have this equation, which is now in slope-intercept form. Slope-intercept form is y equals mx plus b. I now have my slope, and I now have my y-intercept, now that it's solved for y. So now I can use the method I just used previously in those last 4 graphs to graph this equation here. Where on the y-axis would I start? Anyone? Where would I start this line? Not 0? 1. Thank you. We would start at 1 because this right here, it's pointing to the y-intercept is 1. So on the y-axis, we would start here at 1. And then the slope is going to tell us how to get to the next point. What invisible number is in front of the x right now? 1 again, yes. So there's always going to be a 1 here if you just see a plain variable. That means the slope is really 1 over 1. So to get from this point here to the next, I go up 1 over 1, I make another point. All you need is 2 points to make a line. So at this point, you could just connect these two, and you would have your line. Okay, so when you draw these lines, you're going to want to draw them all the way through the graph from the one end to the other. This is a little bit long, but something happened with my board for a quick second. So what we did here is we took an original equation that was in standard form. Standard form equations have the x's and y's on the same side, and I converted it to slope-intercept form by solving everything for y. That's not the only way to graph, but it is one way to graph. Previously, we took equations that are in standard form, and we found x and y intercepts and graphed them that way. So that also works as well. Let's move on to the next one. So if I clear this and scroll down, number 2, we have an equation 2x plus y equals 4. What we're going to do is graph this equation by putting it into slope-intercept form. Slope-intercept form is y equals mx plus b form. Basically, that means take this equation in number 2 and solve it for y. So I'm going to circle the y to help me realize what I need to do here. And anything that's on the same side as the y needs to be moved to the other side. That means this 2x here, I have to move that to the other side. Because it's a positive 2x, what would I do to move it to the other side? Yes, thank you. I'm going to subtract it from both sides here. So minus 2x minus 2x. When I subtract it, it goes away here, and I'm left with y equals, which is exactly what I need. Now, just be very careful with this here on the right-hand side. 4 minus 2x cannot be combined. These are not like terms, so I can't do 4 minus 2x and say that this is equal to 2x because 4 minus 2 is 2. You can't do that. Also, right now, the way that it looks is not the same way that it should look in slope-intercept form. Notice, in slope-intercept form, the number with x comes first and the plain constant number comes second. Right now, the number with x came second and the number that's constant is first. What I'm going to do is rewrite this in a different way. I'm going to flip these around, but when I do flip them around, it's important to realize that this is a negative 2x, so I have to write negative 2x. And this is a positive 4, so it would be plus 4 like that. You're allowed to always flip numbers around. You just have to make sure that you keep the same negatives with them if they have it. So now we're ready to graph this equation. Now that it's in slope-intercept form, we have the slope and we have the y-intercept. To graph this, we start at the y-intercept. What is the starting point for this graph? What is the y-intercept?
Starting point is 4.
Yes, thank you. 4. So we're going to go up to 4. 1, 2, 3, 4. And that's because this b here, this last number, this is the y-intercept. So that's going to be our starting point. So I have that already on the graph. It's at 4. And then this number here is our slope. So our slope in this case is a negative number. The slope is negative 2. Anytime that you have an integer with no fraction, to make it a fraction, you put it over 1. Because it's a negative 2, that means we will be going down and over, not up and over. When I look at my graph in the end, the line should be going down. It should be decreasing, not increasing, and that's because the slope is negative. So from 4, I go down 2, 1, 2, and over 1. And all you need is 2 points to make a line, but you could keep going if you wanted to keep the pattern going down 2 over 1. But once you do 2 points, then you can connect your line. And then that's it. Now, as we move through more examples, these are going to get a little bit more difficult. So we have 2 more left for today. I'm going to clear this, and if you flip this over, well, if you just look at your next page should look like this. These 2 are a little bit more difficult than the first 2. So looking at these equations, I have here, I'm just going to rewrite this, negative 4x plus 5y equals negative 10. We need to convert both of these equations into slope-intercept form. That means we need to take both of these equations and we have to solve them for y. So when I do that, I'm going to circle the y here, and I need to realize that this is going to be a little bit more tricky because I have 2 things to get rid of. I have to get rid of this negative 4x, and I have to get rid of the 5 in front of the y. Let's move the negative 4x first. The opposite of like a negative 4x is a positive 4x, or the opposite of this minus sign is a plus sign. So I'm going to add 4x to both sides first. When I add 4x to both sides, this left-hand side cancels out like this, and we have 5y equals, and then there's 2 ways you could write this. This is a negative 10 plus 4x, or 4x minus 10. You can write it in either way. I'm going to write the 4x first because the number with the x always comes first, and then I'm going to write the minus 10 second. So what I did here is I took this, negative 10 plus 4x cannot be combined together because they're not like terms. Instead of writing negative 10 plus 4x, I wrote it the opposite way as 4x minus 10, which is still equal, but I did that because in slope-intercept form, the slope comes first, and the slope is always the number in front of x. So to make it easier for myself, I wrote the number with x first. Now, the last thing we have to do to solve this thing for y is get rid of the number in front of y. If you remember, whenever there's a number in front of a variable, that means it's being multiplied. This is 5 times y. To cancel out multiplication, we do the opposite, and that is division. So I would divide this by 5, and I have to divide everything by 5. So literally everything gets divided by 5 so that I can cancel out the 5 in front of the y. One way to show that is by doing divided by 5 for all of the different terms. Or you don't even have to do that. You could have just done this, 5y equals 4x minus 10. You could just show by dividing 5 here and dividing 5 here like that. But the reason why I split it up is because when you're dividing everything by 5, you have to make sure you're simplifying things as you go. 4 divided by 5 times x is what this says, or 4x divided by 5. I can rewrite this as 4/5 x. You're not going to put it in decimal form. You're going to leave it as a fraction. Slopes are fractions, so it's totally fine that you have a fraction there. You should see a fraction there. And then the last thing you have to simplify is this minus 10 divided by 5. So you could use this as a negative 10, and you could just do negative 10 divided by 5, which is negative 2. You could use your calculator for that. And then a negative 2, you would just put minus 2 here, and that would be your answer. So this equation is now in slope-intercept form. That's because it's solved completely for y. That means that this number here is my slope, which is the direction to get from one point to the next. And this is actually my starting point where I would start on the y-axis. So because it says a minus 2 here on the y-axis, I would start at negative 2. I would make a point. And then from here, I would use my slope to get to another point. Slopes always tell you 2 things. They tell you how much to go up and over, or how much to go down and over. Because this is a positive 4/5, I will be going up and over because the number on the top is your rise and the number on the bottom is the run. So from here I go up 4, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. I make a point and then connect those points and I have my line. So this does take a lot of steps, and you have to be very careful with the process, making sure you don't mess up along the way. Your exit ticket out of here is completing number 4. In number 4, I want you to first take this equation and solve it for y. After you take the equation and solve it for y, then graph it on the coordinate plane. I'll go over this with you before we leave today.